Today we're going to start trigonometry. Trigonometry is usually a nice subject for math students. We kind of have a good idea about triangles and angles and things, and we're going to rely on formulas, and we're going to rely on our calculator. So trigonometry is a branch of mathematics that studies triangles and angles. And again, angles, and I guess we're going to say sides too. Now remember, Pythagorean theorem is a triangle formula, but Pythagorean theorem only works for right triangles, and grade 11 trigonometry deals with obtuse triangles, and we're going to look at that in the future. But grade 10 was right triangle trigonometry, and grade 11 is really obtuse triangle trigonometry, but there's many similarities. So an angle theta, we're going to use different letters for angles, but theta is a Greek letter that is an angle. Alpha is another Greek letter, and beta. So usually when we talk about angles, we're going to use theta, but sometimes alpha, sometimes beta, depending, and sometimes just ABC. So an angle is in standard position, a little bit new vocabulary. It is in standard position when it's measured counterclockwise direction from the initial arm to the terminal arm. So initial is start, terminal is finish. And our initial arm is always going to be the x-axis. So I'm gonna arc out theta. Here in this example over here, this is our angle. And obviously that's greater than 90 degrees. And an angle greater than 90 degrees is an obtuse angle. So normally we have angles like an acute angle, an obtuse angle, a 90-degree angle, a straight angle. Straight angle is 180 degrees. But we're going to focus on obtuse. So in our idea, our initial arm, as again, as it says in our notes, would be the x-axis, and our terminal arm is basically, where our line segment finishes. So imagine just sweeping that out counterclockwise, and that's our angle. But again, what we're going to do is we're going to go all the way around. So we're going to be interested in not only 0 to 180, but we're going to set up 0 to 360. So of all these angles we could imagine, starting at 0 and just spinning counterclockwise, we can go from 0 to 360 degrees. And these angles are located in 4 quadrants. So quad meaning 4. And in the picture here, the top left is quadrant 1, and then we go again counterclockwise around. So here's our 4 quadrants, and it's important that you simply know quadrant 1, 2, 3, 4. Okay, so let's locate some angles in standard position. And again, it's this idea of, we always imagine a line segment, a radius if you want to think about it that way, or a ray, and we're going to start on the x-axis and we're going to rotate. So our x-axis is always 0 degrees, and that's 90 degrees. So imagine we're swinging, and here would be 180. So obviously 100 is between 90 and 180. So when we draw our picture, as accurately as you can, because that's going to help. It doesn't have to be perfect. So again, I imagine I sweep this angle out, I start here, and I go to 100 degrees. So again, just this idea of where 90 is, where 180 is, etc. And of course, our angle lies in quadrant 2. Well, if we had 295 degrees, well, we would go 0 90, 180. We're still not there. The next one down is 270, and then we're going to swing back to 360. So again, in this one right here, it's 25 degrees more than 270. 295 minus 270. And again, we don't have to draw the perfect picture. All my angles kind of look the same. And here's what we have. So this angle all the way around here is equal to 295 degrees, and it ends up in the fourth quadrant. So we're just locating these angles. And right now you might be looking at this going, whoa, I thought trigonometry is the study of triangles. You don't see triangles here, but that's going to come up later. So let's just do a couple more. And this notion of a reflection, ideally what I want you to be able to do is if I give you an angle, you can quickly and easily draw it. That's the big idea. So here's our picture of an angle, and it's 70 degrees, and it's actually on a protractor, and actually is pretty good, 70 degrees. But here it is right here. So this angle right here is 70 degrees. And what we want to do is we want to reflect this in the y-axis and tell me what this new measure is and what quadrant it's in. So when we go ahead and draw this, we could either count up here 20 degrees. So if we count up here, then the picture is going to look like this. So that's a reflection. It's the same distance away. However you wanna think about it. So our new angle then is this one right here, the reflected angle, and that is, well, I've gone through 90 degrees to get to right here, and we've gone 20 more. So that's 110 degrees, and that's in quadrant 2. So this is going to be a valuable little skill to do, to imagine what something looks like. Here's another example. We're going to reflect it in the x-axis. So in this one right here, in looking at my angle, well, this angle right here is 70 degrees, and we're going to reflect it in the x-axis. So we're going to imagine, well, here's the distance away from the x-axis, and we're going to reflect it that same distance away. So I'm doing circular distance, and when I draw that picture, it looks like that. And when we go ahead and figure out this standard angle, remember what a standard angle is. It always starts on the x-axis, goes counterclockwise. So when we figure out this standard angle right here, I'm going to start here. I'm going to go 90 to 180 to 270. And again, we're going to go 20 more. So our angle turns out to be 290 degrees, and it's in the fourth quadrant. So we want to be able to simply locate angles today, this lesson, and figure out what quadrant they're in, and that's going to be an important thing to be able to do. So again, this is called standard positioning. But as seen in the previous example, each angle in standard positioning has corresponding acute angle. So if we go back to this thing right here, again, when I asked you to reflect in the y-axis, our 70-degree angle, I'll highlight it right here, would turn out to be this same 70 degree over here. This 70-degree angle right here, again, an acute angle, would correspond to this 70-degree angle right there. So if you think about it in this way, what we're basically saying is, even though we're not drawing acute triangles, we're drawing these, well, sometimes these really weird triangles when they, in standard positioning, we can actually imagine a right triangle in each quadrant. And these angles, these angles in these acute triangles are called reference angles. And here's a really easy way to think of a reference angle. A reference angle is your grade 10 trigonometry, because it's always going to be acute. It's always going to be a nice grade 10 triangle. So each reference angle, and we're going to call them theta r, theta is going to be our standard position angle, but theta r is going to turn out to be probably more important, is an acute angle formed between the terminal arm, so where you stop, and the x-axis. And you're going to often hear me say make a vertical. So that's this idea of it doesn't matter where your angle is, you're either going to go down to the x-axis or you're going to go up to the x-axis, and that's how we figure out our reference angle. So let's go ahead and plot a few and see how we calculate it. Now I'm always going to highlight the reference angle, theta r. So again, 357 degrees, 355 degrees is, we're going to do our all the way through to 270 and almost back to 360. And here's going to be theta. So theta is equal to 355 degrees. And what we're going to do in order to determine our theta r, so I'm going to highlight theta r in yellow all the time. In order to figure this one out, well, we're going to imagine a vertical if you want to, but I'm going to leave it around for now. And I just need to figure out that angle right there. So we've almost gone all the way around the circle. We can do it in different ways, but I think the easiest way to do this one is 360, which would be one entire rotation around minus the actual theta. And we get 5 degrees. So our reference angle is 5 degrees. So in order to find our reference angle, it's important to be able to plot our standard angle, and we just want to practice enough. Okay, theta is equal to 260. Well, remember in our picture that we did on the first page, there's 0, there's 90, there's 180, there's 270, so we're not quite there. 260 is not quite there, so we're going to go all the way around almost till we get there. And again, it doesn't have to be perfect. And then we're going to draw that. And this is going to be our theta, 260 degrees. But if we imagine making a triangle or the angle formed between the terminal arm, again, this is our terminal arm, and the x-axis, well, here's your reference angle right here. It's that angle right there. And in order to figure out that angle right here, we could imagine, well, we've gone 260 degrees minus the 180. So if here's our 180 right here, then the difference between the blue angle and this black angle is the highlighted angle, and we get 80 degrees. So our reference angle is 80 degrees. So our reference angle is the angle formed between the terminal arm and the x-axis, wherever it is. Okay, one more little example, and then we'll summarize what we found so far. Determine the measure of the angle theta in standard position from 0 to 360. So again, we could, in grade 12, you go around more and more in the 360 degrees, but grade 11, we just care about this. So here's what we know. We know the reference angle is 37 degrees. The angle formed between the arm and the terminal arm and the x-axis, and it's in quadrant 4. So quadrant 4 is down here, and we're going to draw an angle that's 37 degrees. So I'm just going to draw just this angle. Again, it doesn't have to be perfect. And as long as we know that this is theta r. So theta r is right here, and theta r is 37 degrees. But this time, we're doing the opposite. We want to know the theta. And theta is this angle right here. So theta is equal to a full rotation of 360 minus that 37. And that's going to equal 323 degrees. So again, our angle in standard position is 323 degrees. So we're just reversing the process. Okay, in our next one, theta r is 10 degrees in the second quadrant. So again, it doesn't matter how you draw the picture, but the better you draw it, the more realistic. Here's our angle of 10 degrees. So we can imagine, again, we're going up. So here's our theta r our theta r is 10 degrees, but our angle theta is always the counterclockwise distance from the x-axis to that, and we can imagine going all the way to the other side, rotating 180 degrees, and then we just have the 10 that we have to take away. So our angle in standard position would be 170 degrees, which would give us that reference angle of 10. So let's do a quick summary of how you determine the reference angle, which is going to turn out to be really important. Now, this is just a summary. You don't have to go by this. If you imagine it in your head in a different way, then that's fine. So quadrant 1, we're interested in 0 to 90 degrees. And quadrant 2, 90 to 180 degrees. Quadrant 3 is 180 degrees to 270. And finally, the fourth quadrant is 270 to 360. So this is what we've been looking at. So here's a picture. If my angle in standard position is in quadrant 1, that's going to be theta, but it's also theta r. So again, when we imagine our reference angle, it's always from the terminal to the x-axis, or the x-axis to the terminal, might be better. And in the first quadrant, they're the same. And this is kind of like stuff you learned in grade 10, but you were just talking about the angle, not this reference angle. Well, what happens when the terminal arm is in the second quadrant? Well, here's theta, and here's theta r. And we've done a couple of calculations, but a nice way to figure out the highlighted angle is simply 180 minus whatever our standard positioning angle is. What about when our angle is in the third quadrant? So here's theta all the way around, and here's our reference angle, the angle formed between the x-axis and the terminal arm. And in this example, a quick little thing that helps is 180 plus theta. Now again, you don't have to memorize these formulas, just have to a quick little sketch. And then finally, what happens when theta is all the way over here? Well, here's our angle, theta, and here's our reference angle, and what we've seen in an example already. Here's a really nice way to determine theta r.